Hi everyone, thanks for joining us. I'm Martin from Assist Company. I will not be spending too much on the stage here because the stage goes to my colleagues. I will be introducing them quite shortly. Before, it's my great honor to get you some information about who we are in Assist. We are a software development house. Basically, we specialize on transforming these state-centric applications and data into event-driven systems. We are 50 developers, very experienced in Axon, in domain-driven design, and in CQRS. And basically, if you would love to know more about what we are doing and who we are, scan the QR code. You will be supporting with that our page visits and traffic, so our marketing department will be kind of happy and grateful for that. Thanks a lot. But as I promised, today it's not about me. It's about my colleagues, my fellow colleagues, Ondrej and Richard, who will be guiding you through their expertise into the events, Axon, and what it took for us to master the Axon. I believe that these are quite valuable lessons learned about our implementations, and maybe you will benefit from some experience gained from the show we spent with Axon. So, guys, go through it.
Okay. So let me invite you to a journey. We have 45 slides, so it will be more movie than a journey. So I will try to be really very fast. This journey is actually about two dragons. By the way, no real dragons have been harmed during making the slides. It's all CGI, so don't worry, there will be no impact. So this is the architecture of our application. I put here in just for a reference, then you can see it back on the video because I will not be able to describe it in such a short time. Of course, there is unicorn there. So we have defined some stereotypes and we built our application based on those stereotypes. We have the front-end, back-end integration layer and of course Axon server cluster there. Maybe one interesting thing is that projections are part of the front-end. Okay, we have also built cutting-edge observability stack. So we have invented a new metric that is called stuttering, which gives you information about how the backend and frontend are interfacing. Actually, what we are measuring here is how the checkout desk people are busy. If you look on it from this point of view, we are communicating through WebSockets, and it actually says how many threads on WebSocket handling are busy. And if they are busy, they are then standing in the queue. If they are standing in the queue, people are upset, actually. Okay. Yes, and you can see that our trajectory is phenomenal. This is the user acceptance. We have more and more users. By the way, the application is eShop for spare parts of one automotive company, big European automotive company. You see the things around New Year that people were not buying new spare parts, and you see that the adoption is pretty quick. During the holidays, it was a bit slower, but the user base grow fast. We have no troubles, no performance issues, no nothing. Yeah, well, I should warn you before because some of the pictures will be brutal. So now, if you are faint-hearted, close your eyes because this is really terrible. We didn't know what actually happened, but we tried to turn it off and on again, and it worked. So everything was happy. Here you see the orders that were made during the day, and you see that we have really loyal customers because everybody bought in a few minutes back everything. So we didn't have this day anything. Yeah, what was the problem? I don't know if you know the dining philosopher's problem. This is that you have, like, in Axon case, 10 philosophers with 10 chopsticks sitting around the table, and they took one chopstick, and if they manage to take the other one, they eat. The problem is that there is 10 people and 10 chopsticks, and for you to eat, you need two chopsticks. In our end, normally if you can't take the chopstick, you put it down and you wait, and the story probably everybody knows from the university. The thing is that we had 5 minutes timeout, and we have 3 retries. So it gives you 20 minutes of silence if you are in a deadlock situation. So Can we move? Yes, quite quickly we reviewed the architecture. We realized that we haven't followed our blueprint in one or two cases, and that means that in one of our services we had we had some aggregates that emitted commands, that emitted events. We had aggregates that handled commands, and we were also emitting some emitting commands, executing commands from there. And that means that if we are unlucky, the 10 threads that are dedicated for handling were busy, and we were not able to resolve it because actually, well, deadlock, because of this 10 threads capacity. So yes, they are actually patterns. Practically, we try to write everything into the choreography so that you tend to call it saga. So into processes that handle, so that means aggregate to aggregate communication is handled by the fact that there is event emitted, and there is a process that sketches this event, and the normal story. Well, nothing fancy. Yeah. So one dragon is dead. Not a big deal. We handled it very quickly. Deployed new version, restructured a bit of the application. It was pretty quickly handled. Let's go. Yep, 20 days later. This is even more brutal, so I should have warned you again. And the restarts, it was not that easy. It took us really a bit more time before we resurrect the application. And at the moment, we absolutely didn't know what is happening because we already went through the application. We haven't seen any circular dependency. So there is absolutely no problem. There is no way how this can go wrong. No way how this can go wrong. Yes. So we did a architecture review. We did everything. And just, we had wild dreams. And people from my team had wild dreams, and they came to me and said, you know, I had a dream about a knight that is standing between a big avalanche of tickets that writes sequence incremented, and well, I had a dream about a cup which was lots of water with this hydration thing, and this was like something incremented, and well, you know. And we were discussing it over and over again, and there was a third cap that you saw, and there was a pod that was handling a cache, a treasure chest with cache written there. Okay, let's forget about it and let's make a side note. How do you handle sequencers in CRUD systems or database-based systems? It's easy. You have just sequencer in Postgres and you ask for a new ID. In event source system, it is way more complicated. It's actually one of the ugly pattern, or it's complicated. Because what you have to do is that you have to emit an event ID incremented. Because you have one aggregate, and when you want to increment, you want to have a new ID, you just ask for ID incremented. Which means that it has very positive consequences, that you have complete history, because you can align this sequencer with all the business events that are inside. Okay, let's move. Yeah, and there is also something that is called long-living aggregate. Is this a long-living aggregate? This aggregate that handles this sequencing? Well, according to ChatGPT, no. Well, because it doesn't have done state, but our aggregate has done state every day, because we had the ID prefixed by date. So that means it was short. It was just 25 or 30,000 orders, maybe 40, I don't know, but not many. It's continuously evolving. No, it's not continuously evolving. It's evolving, but it stops one day. And is it a central domain concept? Well, not at all, I'd say. Yep. Yes, I don't know if you see down the numbers, but if you have no snapshot on such an aggregate, and why should you have a snapshot on aggregate that it's not long living, because it lives 24 hours. So if you have 25,000, for example, it means that you have 320 million of replays, or actually events that are hydrating, not replays, but events that are hydrating your aggregate. It's already quite a lot. If you snapshot every 500, you have on 6.2 millions. If you make a cache which we will speak about later, there is 0 reads. The ratio is incredible, well, infinite actually. Still you have 25,000 events written. Okay, no problem, we are there. Consistent hashing to the rescue. Guys were always speaking about consistent hashing. Allard, when he presented it, I was okay, that's a very interesting term, what it actually means. Well, it means that you can rely on the fact that aggregate is handled by the same same service, by the same process, by the same container, whatever, application, over and over again. So the routing is consistent. So what we did, caffeine cache. It's super fast, super cheap. Implemented, deployed on production. We have massive processing speed up, and well, you see, we are happy. Yeah, just try to think about if it works in all cases. It's a very good mental exercise. All right, just speaking about the unicorns. Yes, the original increment ID sequence was something like 700 milliseconds, 0.7 seconds at the end of the day, because it was really overeaten, to say. If you make snapshot every 500 events, I hate snapshots, by the way, but what can I do? It's still 10 times, it's already 10 times faster. It's quite good. You just have this nasty snapshots. If you make caffeine cache on top of it, you see the unicorn even haven't seen the obstacle. He just ran away. You're speaking about something like 8 milliseconds. 8 milliseconds on globally distributed system. Consistent multi-master distributed system with 8 milliseconds latency. Well, it's really good. Let's go. Yes. What could go wrong? Yeah. Well, I don't think that the main problem is that this knight has 3 hands. Even it is scary. What could go wrong is what happened if you restructure the cluster. I mean, service stops and the topology changes. The consistent hashing is not guaranteed in these cases. It was super scary, to be fair, because we were running on production code that we thought might really fail in a bad way. Fortunately, we had very quick response for Steven, so he was not on his Nintendo 64. He replied very quickly. I learned it yesterday. That there is something like topology change notification, but it's not implemented in the current version, which we are on version 4. So server team is working on it. So I was kind of despair because, well, there are some other solutions, but at least I asked my DevOps team lead colleague to somehow try to keep everything stable so that we don't have this topology change. The topology change, it's not that easy because you have to have 2 or 3 topology changes in order to have the problem. But anyway, it was scary. Let's move. Okay, finally, I went through the code of Axon framework, and there is fortunately a prevention of this during the apply. The server responds with Axoniq 2000 error, so that you can do retry. So if you have retry, the collision will not happen, or you have a compensation for this collision. And at the same time, there is a new version of Axon's framework released, and this change request. So if you have in this problem, you can handle it this way. By the way, this is the final solution. The ultimate solution. This one works for us, but there is a corner case when it doesn't work, and this is when your aggregate is in a situation that you will get negative policy response, so the command fails. There is not apply, so that nobody knows that the aggregate will not learn the fact that that is outdated. So it is. Think about it. If you don't want to implement this, you don't need to implement this, but you must be aware of this problem. It was not our problem in this case, so we didn't need to be afraid. All right, so but look on the numbers. we had cache size of size 1. Who has a cache size of size 1? One entry. It's beautiful. Cache size of size 1 has 100% hit rate. Who has it? Yeah, well, I would ask raise your hand, but we do. Being on it, we also implemented cache on other aggregates. Many more, but I just put here 2. And look, we have cache size 1000 for 1, 2, 3, I think this is 4 instances or maybe 6, and they are overlapping. And we have hit rate something around 80 to 90%. So that means, and you have it as well. I mean, the same here. We could have more because the bumps can go up or higher. We just have here 1000. We will increase it by next release. And again, search history, whatever search history is in our application, 80%. But this one is the most important for you who are not seeing it, because I've been sitting there and I haven't seen this. Not this, but on the other presentation. There is something that looks like this, then it goes down, and then it's stable. The thing that I'm describing is server open segments. As the application went older or having more and more events, the number of open segments, we have 256 megabytes segment size. So that means how many segments needs to look back. If you have like the storage that it's a tiered storage, and the older tiers are slower, it's very important for you that you don't need to go into the old ones. And look, it is not the snapshots. Well, of course we have the snapshots. No, well, we had them for the other aggregates. We haven't had them for this increment ID for the increment for the sequence ID aggregate. But that means that since July, the application doesn't open more segments like on average. This is extremely important because that means that you have like flat performance with growing number of events. This is a breakthrough. Yeah. This is the most important slide that I want to show you, because I think not many people were thought about it. This is known. This means that older events are less important than the newer events. They are still important, but they are less visited. Simply because they are old, and you don't need them for the new aggregates. You don't need them. You need them when you do some replace or something like that. But this power law distribution, maybe you know it as like Pareto, this 80-20 rule or something like this. You see it everywhere. It was even mentioned by the Python guy here, and Veritasium guy, and the small world networks like this 6-dimension of world. That means, for example, that you have someone who has really millions of followers on social media. You have some people who are some cities that are really big, there are very few, and the majority of the cities is small. This is in the wealth, but this is in the rivers, this is in the earthquakes, this is everywhere around us. This Pareto-like or power law distribution, Taleb distribution is applied. And cache is actually the answer for it, because if you have only few hot aggregates, which you typically have, because look, why JPEG works. If you try to JPEG white noise, it doesn't work. But if it is something like picture view, it works very well. And this is the same case. There is the skewed distribution of active and non-active users, baskets, spare parts, whatever. And that's why you should always be using the cache, and it will aggressively help you with the performance and also with the performance of the server. Okay, so actually we killed 3 dragons because, yeah, circular dependency, spoke about it before. Hydration, this hydrize, well, it's not dead, but it's actually dead. But we also resolved the tiered storage problem, because in the tiered storage you want these older tiers to be cheap. That means that they must be slow. And if you really manage to have those old tiers not that used, that's a problem that has been resolved. Yeah, so I think this was our last problem. We resolved it, and I think that we passed the rite of passage. And by this, I will give a word to Ondrej.
Yeah. So, I'm not sure if my mic is up. Okay, yeah. So, we have presented this whole optimization to our client, and maybe this happened to you too. They were like, okay, that's cool, but have you heard about AI? We want AI because everyone now has AI, so we want it as well. We have spare parts eShop, and we want to create recommendation because when you need to buy something like oil filter for your car, you mostly change both filters, like air or cabin or everything else. So we want this, and we want this to be done by AI. Can you do that, guys? We were like, yeah, why not? Let's see. Okay, we can go. And because why we could have said that we can do it, because we have event store of orders for last several years, and we know how our clients, customers, the end customers behave, because we have the whole history. Yeah. So now we just need to make some sense of it. So there were some challenges. The first one was product catalog. We actually have more than 110,000 unique spare parts. So the matrix was quite big, and we have several million orders to train on. So we split our data like 80-20 and all that. And what was also really like necessary was the applicability thing. Yeah, because when you do clustering, I will get to it, but when you do the clustering analysis or something like that, what will happen is that oil filter from I don't know, Fiat Panda and oil filter from Mini Cooper will be really close to each other because they're both oil filters. But you cannot recommend air filter from Fiat Panda to BMW guy because that will not just work, right? But we have solved that as well. We can go, and first tries were just like, okay, they need AI because they think they need AI. Let's try it without AI, just do linear regression or random forest or something like that. It will work, it will be fast, it will be cheap, let's do that. We have tried, to be honest. The results were not great, so we have moved on and we actually went to Word2Vec. Can we go? And Word2Vec, I believe most of the guys or girls in this room know. It's a neural network algorithm that turns words into vectors. You can say how big the vector or how many dimensions the vector will have, and based on that you can either have like really dense model or spare model, it depends on you. And we did just that. We took each part from order as a token. Of course, when you are doing something like this, you need to cut through the dataset because not every order has like several parts, so you don't have a way to recommend because the order doesn't have the data. And also, there were so many parts that we just couldn't use every part because of many corner cases for some obscure cars in Europe. So we just took parts that were in at least 5 orders, I believe. So it's a bit more relevant. We created basically 2 models. I will speak about it later, but we used parts as tokens and we used orders as a whole sequences. And what we did is we also created 2 model embedding. We can go there, and this is the thing I want to talk about most. We did 2 models that were then used to build neural network, and the first model was just parts model. Yeah, take the parts and see the clustering in the vector model of what it will do. Yeah, it was actually really good. It was in the, I call it maintenance clusters. It's like when you need to change your oil or timing belt. All timing belts were near each other because it made sense, but also we saw things like sorry, if you are unfortunate, you're in a car crash and you have one part like left doors from the driver, you usually need like rear view from the same part. And actually what we saw is that this clustering happened. Yeah, you had like left doors with left mirrors, right doors, right mirrors, etc. What we did then is use this 128 dimensional embedding, where we also did some logic on VIN numbers. VIN is unique identifier of number. I think everyone knows that, but the thing that maybe not everyone knows is that there's some logic in the VINs. We can go, I think. yeah, I'm not sure if this is visible well, but the thing is that if you have win, the first three symbols are dedicated to each manufacturer. So like this is for BMW, this is for Honda, this is for Renault. This is unique, so if you take that, you always know that these three numbers are Renault, this is Honda, this is BMW. But also the thing is, we can go maybe next. Yeah, the thing is, we did this P as producer, it was, I believe, and the C underscore. This first, I think, 9 characters are for model. So you know that, I don't know, this is BMW 5 Series, this is like Renault Clio or Laguna or something, this is Honda, and you know that this is the specific car because it has this VIN, and the rest are meaning something as well, but not relevant for us. So, as you can see, this is basically what we did in the model. We have producer, we have car, model, and we have the parts. These were sentences that were then used, and actually what happened is that we did train the model, but we didn't have to, because only by using like vector analysis in the model we had our results that were actually really good, and using these embeddings of VIN we actually have the applicability almost solved. There were some cases where it was not perfect, let's say, but it was really good, and we had like batch query for 200 random parts with model and applicability, and like 150 of them were actually applicable to the car that was supposed to be maintained. So that's something that we are like really proud of. And we have also had this is just like use only the parts without the car. So the clusters are like how do I say it, and strengthen, yeah, because you have like the clusters will happen here but also here as well. So you have this like 2-layer neural network built on that. We can go. So yeah, because basically I was talking about it, what we saw was like the engine component clusters. It was like if you need to fix your exhaust or cooling or timing belt or anything, the parts that were recommended were actually meaningful, yeah, because it made just sense in the vector space, yeah, because it was near each other. And the manufacturer groupings happened as well. We saw that like Renault parts are in a different space than Fiat parts or BMW parts, etc. And there's actually something we called internally service pattern recognition. It's that there are parts that are just usually bought together when you go to maintenance, like after first 5k kilometers, you go to your first maintenance and mechanic goes and changes the things that are usually broken after those miles or kilometers or whatever. And we saw that those are bought together as well, and they are near each other in the vector space, even though they, from technical point of view, they are not similar, but they are just bought together, so that's what we did. And the results were quite impressive. But they are sensitive, so I can't show you that much. But basically, you see it's a lot of green, lot of green, lot of green, tiny bit red, tiny bit yellow. Cool. Good for us. Why we could do that? The thing is, we can go. Yeah. Technically, this was really easy thing to implement because we have our events, we have projections ready. So, not ready, but the way to run those projections by replays were ready. So we just ask our developer, like, could you make one more projection to us? And they were like, yeah, why not? Sure. So we did that. It was like really fast, and we had the event history, which is something that is really good. And what's the difference between like event sourced application and normal CRUD application, yeah, because we know not only what customers bought, but what they want to buy, because they checked the part before and they add it to the basket and then just remove, and all the stuff is basically in the events. It's in there. That's why I want to say that the context doesn't come from state, it comes from events, and the context was really, really important for this our use case. So I believe that's it for my part, and my colleague will just show you what else we are doing with this system.
Okay, so what we did, I visited our colleagues in whatever, one big city, the business people, and they were kind of, no, I wouldn't say frustrated, but I said, okay, look, we have some business reports, but they are like 1 day late, and this is not flexible, and I want to do my own queries and things like that. So I said, well, why didn't you ask earlier? It's super easy. By the way, this is like not our application. I make it just a simplified view on it. There is a front end with this WebSocket that I described, and then you have queries that are that go to the projection servers. Then you have commands that there is this domain aggregate service. There are normally many more, like you saw it at the beginning, but I really try to simplify it. Aggregate emits events. Events is distributed through the event bus, stored in the event store, and the projection service listens to it and modifies the projection. In this case, I call it OLTP projection because it's intended for the transaction processing. Can we? Yeah. And we extended the architecture, but it looks scary, but no, it's not. Because the only thing that we added is, well, actually this part, maybe I will speak about this part later, but it's not that important. We added this part, so that means that we had another projection service. We connected to the bus, and we built in Postgres like analytical projections. By the way, these projections are in Mongo Atlas, and those projections we put just in next to the application RDS on AWS in Postgres, and we connected Grafana to it because we know Grafana, so it was easy for us to write some queries and make some dashboards in Grafana. So what I'm actually speaking about is this super simple thing, just projection or projection service, projection database, Grafana, and the user interface to the Grafana. It took us like hours actually. Yeah, what are the benefits? What you can do with this? You have the complete historical insight, or if you have all the events, you can do the complete historical events. All the business events that are there can be somehow projected, and they can be queried. You have fresh, low latency, like sub-seconds. We have like half second or 200 millisecond. I don't know, maybe 2 milliseconds. I don't remember, but it was definitely sub-second. So you do the refresh, and the reports are just in time. And just in time, I mean really just in time. If you want new, then it means that we can deploy quickly new projection. It is really a question of 10 minutes, as Stephen said. And there is another thing. That you have the Postgres that you build, you put there only the data that are not sensitive, because there are some IDs that are sensitive, there are usernames or client names or whatever. You don't put it there because analytical people don't need them. So you just rebuild the projection with the normal data. I know it's just a normal jest. It's something that you do normally because it's just event sourcing, no surprise. But it was really eye-opening for our colleagues. What you can also do, you can do some A/B testing, and you can have immediate feedback from after the deployment. You see whether version A or whether version B performs better from the convergence point of view. Just in time, you don't need to wait for 24 hours for the reports being crunched. We can detect fraud use of the application, and we can discover unimplemented features. So I will show it in later. Okay, so this is how we reply I described it. We just reply the event. It takes few hours. Here is how many events we process per second. Here is the latency dashboard, latency panel. How the processor is busy and which events are being replayed. So we observe how it is. And as well, the first second when we start, we can start querying. Of course, we will have this 2.5 old year data, but in few hours we have all the history, so we can query everything. Yeah. So, for example, we are chasing for the free riders. These dragons that are riding for free on the unicorns. They are people. They are using our application that way, that they are searching for some spare parts using the VIN or whatever, the identifier, and they are not buying. So we created the projection that actually contains this. It's very easy. Just few events that you just glue together, And I created this histogram in Grafana. Well, creating histogram in Grafana in this shape and form is quite difficult, by the way, but it's doable, evidently. And those are people who have 0 to 5% conversion. This guy, this green guy, is well, no, the dragon is not green, it should be green, because he really misused the application. He haven't had any order, but well, this is 7 days, by the way, I think. But he made lots of searches. So well, he doesn't have access to the application anymore, by the way. And you can see it just in time. So yes, another one. This is funny. I was just checking which car is the least reliable by the VIN. 220 something in 1 year. That means that he does it mean that he visited the shop, the workshop, like that many times? Well, no, there is not that many working days. It means that someone bookmarked this, because if this car is, I don't know, Fiat 500 arrives, and the guy who is doing the repair, he just look on the car and says, ah, this is this model, I know this is this VIN, and clicks it. So this is a use case that the UX guys should have taken into account. They haven't. They can now, because they see it. Can we move? Yeah, and this is the contract breach. Well, someone has started search like crazy. He's not anymore. Where's the X-Man? Over there. Yes, and we can see the adoption rate. Easy. New users, users that stay with us. Again, New Year, holidays, and the total number of users.
Yeah.
And it's yours.
Okay, and just one more thing from me. It's how we did a new, let's say, cybersecurity antivirus application that's turning files into events. It's now our new, we call it CVV platform, and it's like event-driven application written in Java, run at AWS, connected to Axon server. And what we really like about that is the event store is immutable. And this means that if someone like from forensic department came to us and asked, you know, this file, I believe like 2 years ago this went through our scan, can you check for that? Yeah, we can, because we have the truth. Okay, I will just show you really quickly what happens with the file. We ingest this file from business application from same client that just calls our application via IPG. Our application creates pre-signed URL. This is then sent back to the business application in a response that uploads using the pre-signed URL, uploads this to the bucket. The arrival triggers SQS message, which is then sent or polled by the CVV application. We have some antivirus scanning, and then it just makes the verdict clean or dirty and can do anything else with the file. We can pass it further, we can delete it, we can leave it for forensics to check, if, or maybe even for us, because we don't know if it's false positive, false negative, could be both. And yeah, that's just what are the main positives. It's really good in scalability, and it's auditable, as I just told you. It's a single source of truth because we have the events, we have the truth. Queries are usually really fast, and what we really like about that is, as we learn about observability more and more, we can do is just like standard part of our job. Standard tooling for us is observability as well, on really good level. So that's I think that's it. We'll just fast overview.
Yeah, thank you very much. I come back to this caching aspect.
Yep.
It sounds so good that I wonder why we not all do it.
Me too.
I remember that, so it's also a question for Stephen. In Axon 4, at least the Spring Boot world, we had this pluggable weak reference cache on the aggregate. How is this completely different, and what are you planning for framework 5? Do we need it, or?
You need it, but he has to answer that. You need it.
Yeah, that'll return for sure. It's not in there in 5.0.0 yet, but yeah, because of the obvious benefits. So.
How is the copy different?
No. It's just we used what they have provided us. I mean them. So there is event sourced, cached event sourced provider. I think is the name of the class, if I remember well. So yeah, so we just use Cafe cache there.
If you don't want, that's the last part with the OLAP Grafana thing.
Yeah.
I was in the workshop yesterday, so again, also a question for Axoniq. The analytics node of the new Axon server setup has an SQL representation of the data, so maybe this is a step we can skip in the future, or what are your feelings?
We don't know yet.
Yeah, well, I can comment on the. I've been thinking about it because when they presented, I said, "Well, actually, do I want to change my presentation?" But over the night, I was like just lazy to just do new slides about something totally different. We do lots of interesting things, so I would have to find different interesting things and find different dragons and so on. So it will be difficult and lots of time. But thinking about it, not everything is like queryable easily through SQL. So the difference is that what they have, they have like, I think, quick access, very quick, thanks to Parquet, access to the events, but sometimes it is so complex, I think it is so complex to express the need of looking on the data through SQL that it will be easier to do it in 2 steps, like, okay, let's build me projection, and then I query the projection, maybe also for speed reasons. So that's trade-off, of course, because we need to do the replay, and in our case, it's several hours.
Okay, so it depends.
Yeah, it depends. Yeah, of course.
Thanks. I think this is it. Thank you, Richard and Ondrej. Let's do another round of applause for this.
Thank you.
Thank you. Thank you.